Welcome to this session, the first one of many, I hope, of our mentoring space. We create this space that is called Cybersecurity for Everyone, thinking about the lack of practitioners in the cybersecurity area. So we want to help a little bit with these sessions. So today we are going to talk about OSI model, TCP-IP model, and network analysis or network traffic analysis fundamentals. So we're going to share some resources today. I'm going to publish those resources in my GitHub as well, but we are going to use public resources so any person can have access to the resources. So let's start talking about the OSI model. So I'm going to share with you this link so you can use it and you can review it. It's in the chat. All the links are going to be in the chat. So OSI model. It's a model that it's the basement for networking. So normally it's composed by 7 layers. And one of the most important parts that we need to understand each one of these layers. So we are going to understand what is going on in each one of them. If you understand, or well, if you want to understand networks, you need to understand OSI model. So the first layer is the physical layer. That means that it's talking about the wire, the electronic media that you are going to use to transmit the information. We are talking about here related with switch, wires, network cards, etc., the physical part. Then comes the data link layer or layer 2. This is so important. This one is related with the MAC addresses and is the first layer where you see data. So normally, if we are working with an operating system like Kali machine, this is a Linux Kali machine. This is a penetration testing distro. It's free. Just in case if you want to download this tool, it's totally free. You can download Kali for free. The latest version is the 2022.3, and you can download this virtual machine, or you can download the ISO installer, etc. So it's free for everyone. I'm going to put this link in the chat just in case. Perfect. So in the Kali machine, we can take a look in the terminal. When you want to query the information about your network card in Linux, you just need to say ifconfig, and you can see the information about the different network cards or interfaces you have in your machine. So here we have the IP address. Here we have the netmask broadcast address. I'm going to explain that in a moment. And we have here IPv6 and the MAC address. This MAC address is composed by hexadecimal numbers, normally 6 of them. And one important thing that you need to understand is that the first 3 numbers of this MAC address are related to the vendor, to the maker of specific technologies. So this allows you, if you are going to work in a blue team or similar, this allows you to understand which one is the brand of the device you are sending traffic or receiving traffic in your network. Let me go a little in deep about this. We can use a tool that is called MAC Changer. That is a very interesting tool that allows you to change the MAC address in your machine. Some people think that you can't change your MAC address because the MAC address is a hardware address, normally connected directly with your network card. But you can change that MAC address with different tools. In Linux, you can use MAC Changer or you can use Python. In Windows, you can use tools like SMAC or similar to change your MAC address. But let's talk a little bit about this tool. Like almost any tool in Linux, if you want the help about this tool, you just need to say -h or --help to see the help of the tool. In this case, we have the help, and they say, well, if you want the help, h-v the version, etc. But one of the most interesting things for me right now is to see the list. List shows the different brands or different vendors of devices, and you are going to see that they are identified by the three first numbers. Let me show you. You can say Mac Changer -L, and you are going to see a lot of different vendors. Of course, we pass so fast. So like almost any command in Linux that you want to see page by page or line by line, you can say pipe. So you are going to tunnel, let's say to tunnel or to put in a pipe the answer of the command, and I'm going to say more. So we can see page by page or line by line. If you hit space, you are going to change page by page. If you hit enter, you are going line by line, as you can see, 40, 41, 42, 43, etc. So as you see, the first three numbers identifies hardware, identifies vendor, you see? So if you are talking about, I don't know, if you see in an entire network, if you know that in your network you use, I don't know, Hewlett-Packard technologies, you can look for different vendors. So Hewlett-Packard can be detected. Let's say that we want to look for Hewlett-Packard technologies. Well, we can say Hewlett. We can use a tool called grep. It's using regular expressions. In some session, I'm going to go deeply in regular expressions because they are useful in forensics, in filters, etc. But my recommendation for you, it's if you have time, look for regular expressions. It's very, very interesting concept, and it's very useful in technology. Regular expressions. So you can see a lot of them are used to many things. I'm going to copy this for you in the chat so you are going to remember. Perfect. So we are going to look for Hewlett. But if I hit enter, we are not going to have results. And maybe you are going to think, maybe there is not Hewlett-Packard in this list. Maybe, but no. The problem here is Linux is a case-sensitive operating system. For Linux, it's not the same to say Hewlett with lowercase or Hewlett uppercase. You see the difference? So you need to have this in mind in the moment you are looking for some specific command or for files, etc. So maybe you are thinking, okay, there should be a way to look for the Hewlett string. Doesn't matter if it's uppercase or lowercase. And yeah, there is. So you can say Hewlett, and you can say -I. That means case insensitive. So the operating system don't care if you are using capitals or lowercase. It's going to show you everything. So as you see, you can identify Hewlett-Packard technologies having the three first number of the MAC address. So this is very important, allows you to apply filters in your traffic, allows you to detect weird devices, etc. But of course, as you saw, you can change your MAC address in a very easy way. If we take a look in our MAC address, I can change that to a very, very random address. I can say sudo to execute a MAC change in my operating system. I need privilege, I need elevation, because the normal user Kali that I am right now, who am I? I am Kali user, is not enough, doesn't have enough permissions to execute a system command. So I need to say, if I try, let me show you, MAC changer, MAC changer, I need to provide the interface. I need to say MAC changer. Let me show you with the help. You're going to see that. You need to provide the interface. that you are going to change. So we are going to say MAC changer -m if you want to change for a specific MAC address, but right now I want a random MAC address. So I'm going to say -r to the interface. In my case, ETH0, Ethernet 0. As you remember, we have the ETH0 and a loopback. The loopback interface that normally is only logical, but can work. It's so amazing. In some moment, in other session, I'm going to go deeply in loopback addresses. But right now, we are talking about ETH0. So we can say MAC changer -r for a random address, ETH0. And if I say enter, it says error, could not change, insufficient permissions, because I'm working as Kali user. If I want to do that, I need to say sudo to use the privilege of another user, in this case, root, that is the super user in Linux. So I can say sudo MAC changer is going to ask me for the Kali password, because you are going to thinking, if you are not familiar with Linux, you are going to think, okay, but why it's asking for the Kali permissions? Because Kali, it's inside a group in Linux that is called sudoers. So if you want then a user, a regular user, can execute commands with higher privilege, needs to be inside the sudoers group. And then with the same password of the user, you can execute high privilege commands. So look, the current MAC was this one, and now my MAC address is my new MAC address is this one, totally different. And let me show you ifconfig, and you are going to see the new one. Look, totally different. So maybe you now realize that if you are going to use security in your network and you want to apply a filter by MAC addresses, it's useless, because any kind of malicious actors can change their MAC address. So normally they are going to try to impersonate your MAC addresses, but you can apply filters looking for weird MAC addresses or duplicate MAC addresses. That's so important. I hope this is clear for now. So we are talking about layer 2. And layer 2 can be analyzed in a very easy way. I'm going to show you in a moment. Then you have the network layer. So normally this network layer is used by routers. Previous layer, layer 2, is used by network cards, bridge, switch, etc. Normally these tools, bridge, network cards, etc., allows you to route the traffic from one device to another device using layer 2. This is so important. But in layer 3, normally you have the possibility to use routers to define which one is the best path for the traffic to reach the final destination. You are going to see in a moment that the first part of the traffic is layer 2, MAC addresses. After that, you have the transport layer. So normally you have data here. It's a sequence of data and allows you to execute error recovery, flow control of the traffic, etc. And normally some firewalls can work with this layer to control the traffic. Firewall is a device that allows you to control the traffic and provide security in your network. Then comes the session, so you control the conversations between devices in this layer. Then presentation. In this layer, you provide formatting to the information. So you are going to use compression, encryption, etc., and it's used for a lot of protocols to control the traffic. But different protocols, like encryption protocols, use different layers. One of the questions, very simple question that normally I provide to my students is, okay, in which layer of the OSI model works TLS encryption? And a lot of people say application or presentation. No, it's transport layer security, TLS. transport layer security. So it's in transport layer. So different protocols can work in different layers, right? So that's why it's important that you understand the different layers. And now in a moment, we are going to see that in physical. And we have application. In application, normally, people can interact with the protocols. Normally, we are talking about protocols like FTP, HTTP, DNS, etc. Different protocols can be used in the application layer. A very important thing that you need to understand is that this is a model, just a model. Normally, in real life, you are going to use the TCP-IP protocol. And TCP-IP protocol, as you can see here, have different layers, but those layers are connected directly with the OSI model. So in TCP/IP, you just have 4 layers. Then you have the first layer, it's called network access. And the first layer is composed by the 2 first layers of the OSI model and have the same use. So in network interface, in TCP model, you are going to see the electronic part and the MAC address. Then comes the internet or internetwork layer. So here we have protocols that allows you to route the traffic. Protocols like IP, ARP, Address Resolution Protocol, ICMP, Internet Control Message Protocol, etc. So layer 2 in TCP model. You have the third layer, host to host. Then you use protocols like TCP or UDP. This is very important. Normally, most of the traffic you are going to see, it's TCP or UDP. It depends about the protocol you are using. Some protocols are more oriented to UDP. Some protocols are more oriented to TCP. TCP is Transfer Control Protocol. UDP means User Datagram Protocol. I'm going to provide you some links to go deeply in this, don't worry. And then you have application. As you see, 3 layers, the layer 5, 6, and 7 in the OSI model are compressed in the application layer in the TCP model. It's very important that you understand that in the traffic, you have encapsulation. So it's like you have a big box, right? And inside this big box, you have small boxes inside. So you are going to try to encapsulate the traffic in each one of these layers. And this concept is a little difficult to understand, but if you see this in a graphical way, it's easier to understand. So the first thing that we are going to do to understand the traffic is to start Wireshark. What is Wireshark? Wireshark is a tool that is called a sniffer. And a sniffer is a tool that allows you to capture the traffic that you are receiving or sending in a specific interface, or you can analyze a previously captured traffic. Let me explain what I'm talking about. So, Wireshark, I'm going to show you the link of Wireshark, and you can download Wireshark in your computer if you want. Normally, most of the Linux can have Wireshark embedded. So, it's a nice tool. My favorite is Sniffer. As I mentioned, a sniffer allows you to capture the traffic. That's why the name is Sniffer. Wireshark is one of the best in the history, but it's not the only one. Even Wireshark have command line similar tools like T-Shark, like TCP dump. There is a lot of different tools that allow you to sniff traffic. But Wireshark is graphical and it's very nice. So you can say Wireshark if you are working in Kali or in any operating system, or even in Kali, you have the menu, and you can say Wireshark. And you are going to find it here. I'm going to use it here, and I'm going to put an ampersand at the end, because I don't want that this process take my Wireshark forever and don't allow me to execute nothing else. Let me explain what I'm talking about. If I say Wireshark only and hit enter, Wireshark is loaded, is perfect. But if I go back to my terminal is connected directly with Wireshark. I can't execute any other command because it's connected directly with Wireshark. So it's not possible to use this terminal anymore. If I want to run commands, I need to open a new one. I need to say file, new tab, and I'm going to have a new terminal, and well, that's it. But there is a way to use any kind of tool and provide or send this process to background. So you are going to provide a specific connection to that process, but you can keep your terminal. So you can say this. You can say, let me close the Wireshark here. Of course, I kill the terminal, so the Wireshark remains a little word. Okay, perfect. I'm going to say, you want to terminate the application? Yes, I want. So I'm going to say Wireshark and an ampersand at the end. So now we are going to have our Wireshark, perfect. And we have, let me show you, we have the terminal. We can execute commands. Good. So Wireshark. Wireshark, as I mentioned, allows you to capture the traffic from a specific interface or allows you to analyze a traffic that you already captured. You see here the different interfaces here in Wireshark. Wireshark is a tool that allows you to execute two different types of filters: display filters and capture filters. What is the difference? Very simple. Capture filters allows you to select the specific type of traffic you want to capture in the moment this tool starts. And it's very simple to do this because you can create this capture filter here, and you have here the possibility. Let me show you. Here you have the possibility to select a specific traffic, like only IPv4, or no ARP, or only IPv6, or only TCP or UDP. So you just can capture a specific traffic, or you can capture all the traffic and then apply display filters, right? So you can capture everything and then you say, okay, about this world of data, I just want to see internet traffic or resolution traffic or so. That's important to understand. I hope everything is clear for now. Everything clear for now?
Everything is good for now. I'm really just taking it all in to then like rewatch it later, but I'm following you.
Sorry, it's what?
I said I'm taking it all in right now, but I'm following you thus far.
Okay, perfect. Nice. So we can start capturing the traffic for a specific interface. I'm not going to apply capture filters. I want everything. There are some dogs outside. I hope you can hear them. So here we have the different interfaces like Ethernet 0, any interface, loopback, etc. All the network interfaces are going to be listed here. In my case, I'm going to select ETH0, right? ETH0, and then I can hit Start Capture Packets. I need to provide permissions in my operating system it's not important right now. Good. So now the interface is listening, waiting for traffic. So let's create a little traffic. I'm going to open the browser here, the Firefox, and let's visit a website like secpro.llc. Let's see. So we are visiting a website. So let's see what is going on in the sniffer. Look, in the sniffer, we have a lot of traffic. You see, a lot of traffic. I'm going to stop this capture. One important thing you need to have in mind is that this capture is going to be stored in RAM memory. So if you leave running your Wireshark a lot of time, it's possible that your computer is going to collapse because it's going to use your entire RAM. Well, so as you see, we have everything, all all kind of traffic, and you're not understanding right now what is this. It's very simple. Don't worry about it. We are going to go deeply right now. So we were talking about layers, right? We were talking about layers. So let's see, let's go to the first packet here, and let's click in one of them. As you can see, in the lower part, you have here frame, Ethernet 2, Internet Protocol, User Datagram Protocol, and domain name. So here we have the layers that we were talking previously. So in the layer 2, we were talking about MAC addresses. You remember, I hope. So as you can see, in layer 2, you have MAC address. Look, I'm going to click here, and here we can see the source MAC address and the destination MAC address. And as you can see, this one says this is VMware, because I am using virtualization. VMware is a virtualization tool. And Wireshark is capable to detect that we are using VMware in this machine. This is my Kali machine. And then here we have the destination MAC address that we are trying to reach. And here we can see the type of traffic, IPv4. You see? That's layer 2. We can go to the Internet Protocol version, or the next layer here, and you can see source IP address and destination IP address. You see? Source and destination. So as you can see in the Wireshark, you have the different layers represented in this way. Then you have the User Datagram Protocol. I didn't explain in deeply what is TCP or UDP. Don't worry about it. I just want you to see the different layers. Don't worry.
So this would be, so what it's showing us is basically in the TCP/IP model format, right?
Exactly.
Okay.
Exactly. And normally all the tools in the world are going to show you TCP/IP. Okay?
Okay, so we won't typically see it in OC model.
Never. No.
Okay.
No.
Okay.
Perfect. And then you have the domain name system here. This is the protocol. Okay, perfect. So we were talking about the capture filter, the display filter. So one of the things you can do in Wireshark or in the most of the sniffer is to filter for some specific traffic. Okay, so we can say show me traffic from a specific IP or for a specific protocol, etc. So for each one of these packets, you can see the different layers. You see? And in this tool, if you want to do double click, you can see in a bigger screen this packet representation. So we can see the Ethernet layer, and here we have the header part. This X content, this hexadecimal numbers content here, it's representing the header of this traffic. It's called header. So here we have the Internet Protocol, and we have the IP addresses here represented in X numbers, in hexadecimal numbers. Okay, look, the 172.1645.2 IP is represented with AC10 to the O2. In our session, I can show you how to convert hexadecimal content to IP to decimal number. It's very simple. But for now, I just want you to see the header and the content here. Destination and source are represented here. The IPs are represented in hexadecimal numbers. That's how you are going to see that in the traffic. In the traffic, in the hexadecimal representation, you are going to see that. IP, source IP, destination IP, and so on. Then you have the user datagram protocol and source port, destination port. we're going to talk about that in a moment. And well, the protocol. So an sniffer allows you to see each one of the packets in a very, very deep way. Well, so we were talking about the OSI model, and the TCP-IP representation, right? The OSI model and the TCP-IP representation, and you can see the layers. So now we need to go deeply and understand a little bit about TCP, UDP, and other protocols. So let's start talking about TCP and UDP. So it's going to be easy for you to understand the other concepts. I'm going to copy this link for you. And well, we have the difference between TCP and UDP. TCP means transfer control protocol or transmission control protocol, and UDP means user datagram protocol. The main difference here, it's in TCP, normally, if you send a packet to the receiver, the sender sent a traffic for the receiver, normally the receiver needs to answer and say, hey, I received your information. And after that, the sender says, okay, perfect. And after that, you are going to receive traffic because something that we call session was established. I'm going to explain deeply what is SYN, SYN-ACK, ACK. Don't worry about it for now. In UDP, no. In UDP, the sender just sends information to you. In the same way, I'm saying something here, I'm showing you things, etc., but you are not talking all the time with me. So I'm just sending information, and you are receiving. In some moments, you talk to me, and in that moment, we can say, okay, it's like TCP, because you are talking to me. But when you just send information, you are using UDP. And each one of these protocols are very useful for different things. For streaming, UDP is perfect because you just need to see the movie. You don't need to interact with the movie or with the soap opera or any kind of content you are watching, Netflix or similar, right? Or in YouTube. Is like UDP. You just receive, and YouTube servers just send you information. That's UDP. But in a conversation with a person, normally it's like TCP. Is clear this concept for you?
Yeah, that makes sense.
Perfect. So there are more protocols and different level protocols. There are protocols like ARP, Address Resolution Protocol. That protocol is using MAC addresses to define the destination or the path that the traffic is going to use. Normally, the technologies that we use to create networks like switch, routers, etc., they use MAC addresses to define the location of a specific machine. It's important that you take a look to a concept that is called CAM table. Let me put this. CAM table, that is the list of devices in a switch. That means content addressable memory. So in a CAM table, in a switch, maybe you're familiar with a switch, right? I hope you're familiar with switch. Let me show you. I'm going to show you an image of a network switch like this. These kind of devices allow us to connect different devices, right? Different computers or devices in our network. So these devices use the CAM table to know where is located a specific machine or a specific device, you see? So a CAM table is like this. It's not so good, the resolution. Let me reduce a little bit. Maybe this is better. And I'm going to copy this link for you. So as you see, ARP use MAC addresses. And ARP is used in the CAM table in the switch to know which port it's used by each one of the stations connected. So as you can see here, each one of these stations have a MAC address, an IP address, and in the switch, you have the CAM table that knows in which port is connected the MAC address A, B, C, D, etc. So the first part to select the routing to know where to send the traffic is using MAC address, layer 2 in the OSI model, and is used by the switching technologies. I hope this is clear.
I'm following you still.
Perfect, perfect. Please, if you need me to repeat something or go deeply in a concept, just let me know.
Will do.
Perfect, perfect. So, ARP. If you take a look in your you are going to see, look, ARP protocol. One of the most beautiful things in this kind of technologies, in this sniffer, is that you can filter for a specific protocol. You can say ARP, right? Sorry, not caps. ARP, enter, and look, it's going to filter by protocol. So you can see the ARP traffic. And you can see that you have a question saying, hey, who has the 172.16.45.2? But it's using the MAC address to send that question in broadcast. You see, broadcast. So this question is sent to the entire network asking, hey, who has this IP? And please, if somebody knows, tell to 172.16.45.175. How do we know that it's a broadcast communication? Well,
the destination.
Yeah, here you have here broadcast. FF, 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 FF. You see?
Uh-huh.
So all the machines in the network are going to receive this question. So if someone is the 172.16.45.2 is going to say, hey, it's me, to the 172.16.45.175. You see, this is address resolution protocol, one of the most important protocols. You can take a look about that one. ARP protocol.
And you said that was address resolution protocol?
Exactly. Address resolution protocol. Okay, address resolution protocol. I'm going to copy a link for you.
Thank you.
No
I'm
problem.
saving all of them. I'm making a new folder.
That's great. That's great. Perfect. Well, good. So, that's ARP. You can apply filters here, right? Like TCP filters. If you want to see all the TCP traffic, you can apply a filter here, TCP. And you are going to have all the TCP traffic, or you can apply UDP. Sorry. You can apply UDP filter, and so on, so on, so on. You can apply different filters. One important thing for you to understand is here you can see a green mark, yellow mark, sorry. That means that the filter is okay, but can be better. That means it's not the perfect filter. A difference, like I can say ARP, and you can see this is blue. It means you're okay, no problem, no problem, and this is green. But if I apply a filter that can be better, it's going to show you yellow mark. So, yellow marker, perfect. So we were talking about the different traffic. So we already talked about ARP. Let's go to TCP a little deep. In TCP traffic, as we were talking before, you have the possibility to establish a session. And how you can establish a session? Well, it's very simple. You are going to use flags. You are going to use flags. Those flags allows the receiver to understand what you want to do, right? So let me explain a little bit about those flags. I don't remember if I already shared with this link with you. Yeah, I already shared.
Yes, you did.
So I'm going to explain the flags. There are 8 flags that you can have in TCP, but normally you are going to use only 6 of those flags. Those 6 flags are SYN, that allows you to establish the communication. It's like I can tell you, hi. That's the hi in the protocol, in TCP protocol. SYN. It's just to start the communication. Acknowledge, ACK. It's used to say, hey, I received your traffic, I received your information. Don't worry, I already received it. Acknowledge. Fin flag means that you want to finish the communication in a polite way. It's like when we finish our session, I'm going to say, okay, bye, see you guys. Reset, RST. It's a flag that is used to cut in an abrupt way the communication. Reset. That's used when somebody wants to connect to a closed port, and of course the port is not going to receive any kind of traffic, so normally the answer is going to be a reset. I'm going to explain the port concept in a moment, don't worry.
Okay.
Urgent, URG, is the flag that you are going to use to provide priority to a specific packet. Urgent pointer. SYN, FIN, reset, acknowledge, urgent, push. Push is the flag that you are going to use when you need to clean the buffer, the buffer transmission. If there is some repressed data in the channel, you're going to use a push to push the traffic and try to clean the channel. So SYN, FIN, push, or reset, acknowledge. 6 main flags. Those flags are here, so you can see each one of them. I'm going to share with you this link. So each one of these flags allows the sender and receiver to know what is going on. And having that in mind, we have one of the most important concepts in TCP traffic that is called three-way handshake.
Okay.
What is that three-way handshake? It's very simple. It's what we have here in the previous slide, or in the previous side. Look, when a sender wants to talk with a receiver, normally starts the communication with, let me use the pen here. Let me use the pen, draw here. Yeah. So the sender wants to talk with the receiver. So the first thing that the sender is going to do is send a SYN packet, as you can see, a SYN packet to the receiver saying, hi. And that packet is going to be sent to a specific port. How is that concept? It's very simple. We were talking about protocols before. We say, okay, can be HTTP, can be DNS, etc. But what is that? Very simple. When you are trying to open a website, you are going to use 2 possible protocols, HTTP or HTTPS. Those are the protocols that are used by web normally. Mm-hmm. If you want to know where is located a specific domain, you want to know, okay, which IP is secpro.llc. Okay, you are going to use a protocol that is called DNS, Domain Name Service, and you are going to execute domain name resolution. It's another protocol, DNS. If you want to use mail, your email, you can use IMAP protocol, or POP, Post Office Protocol, or SMTP, SMTP is simple main transfer protocol, and so on, so on, so on. So each one of these protocols can use different ports in TCP protocol. And maybe you are thinking, okay, how many ports can exist in TCP protocol? 65,535 ports in TCP model. And those ports can be used by TCP protocols or UDP protocols. And inside each one of these protocols, you have different protocols like HTTP or HTTPS, that is TCP, or DNS, that is UDP.
Okay.
So I'm going to clarify more in a moment, don't worry. So in this case, we're talking about three-way handshake, TCP protocol. And as you can see, the first thing that the sender does with the receiver is send a SYN flag to the receiver just to know if the port is open. And if the port is open, the receiver is going to send a SYNAC. And then the sender is going to say, okay, perfect, your port is open. And after that, you are going to send data. Let me show you in a graphical way, so this is going to be clear. Let me clear all and mouse. Perfect. Let's go to our sniffer. And here we can look for a specific port traffic, like HTTP traffic or HTTPS. Maybe, let's see, TCP.port equal to 443. Let's see if we have that kind of traffic. And yeah, we have. 443 is the port used by SSL traffic. When you connect to a website using HTTPS, that means that the traffic that you are sending is going to be SSL or TLS, right? It's encrypted traffic. And that traffic normally use port 443. If you want to see each one of the services in each one of the ports, there are different ways to know that. In Linux, you have a beautiful file that is called services. Inside etc is called services. You see, let me put a more here. And you can see the different ports for each one of the services. Look, port 53, domain. And domain can be used in TCP or UDP.
Okay.
Think about TCP or UDP like language. So you can say hi in English, you can say hola in Spanish, and so on, so on, so on. So some protocols can be used in TCP or UDP. In other session, I'm going to go deeply and explain, okay, you are going to use UDP in this case, or you are going to use TCP in this case. Okay. So look, you can have a lot of them. Look, 443, HTTPS. HTTP protocol over TLS or SSL, you see? That's why my query in the sniffer was TCP.port 443, because I want to see the HTTPS traffic. Is this clear for you?
Yes, it is. Perfect,
makes sense. Nice. So you can see some of them. There is not all the 65,535, because not all of them have services associated. Not all of them. So if you want to see the services associated, you can take a look. Normally, from 0 to 1024 are very well-known ports. So let me see, let me show you. TCP ports, and well, TCP ports list. You can take a look. So you are going to have all of them, or the most important. Some of them are reserved. You see, here you have the table here. You can have in Wikipedia, but let me see if there are a better explanation here. Well, here you have the list. Not all of them, not all of the ports have a specific service. Normally, you have 3 different levels of ports from 0 to 1024, and from 1024 to 49,151, and so on. But don't worry for now. So you can take a look about the different ports. I'm going to share this with you. Perfect. So let's go to our sniffer, and we can continue in the explanation here. So as you see, we were talking about three-way handshake, and you can see in perfect way the three-way handshake here. Look, here we have SYN, SYN-ACK, and ACK. So my Kali machine with this IP, you remember my IP? Let me show you just in case you just forgot the IP. Of course, we forgot the IP. Let's see. ifconfig. We have the IP address 172.16.45.175, right?
Mm-hmm.
So we can see in the Wireshark, look, my IP, my Kali machine send a traffic to this IP 18.164.96.195, and the destination port was 443. Normally, in a communication, you have a source port and a destination port. So normally, you can use any port, normally over 1024, over 1024 to a source port, and the destination port needs to be the specific protocol port that you want to use. That's where you can see that my source port was this one, 54,284, but the destination port in the website was 443. So you can use any source port, normally over 1024, but the destination port needs to be the specific destination port, depending the protocol. Is this clear?
Yes, I have a question though, and
Yep.
this may be a silly question. When you're making the request, so you made the request to port 443, will it always be a TCP like conversation, or will some ports only give you a UDP type of response?
Excellent question. We are using the HTTPS protocol. That's why it's TCP.
Okay.
Some protocols use only TCP, some protocols use only UDP, or some protocols can use both.
Okay.
Perfect.
So if it were just like an HTTP, it would just be a UDP?
HTTP use TCP as well.
Okay.
DNS use UDP. The most of the times, when you as client connect to a server, you are using UDP. I'm going to show you in a moment.
Okay.
Perfect. So look, you sent a SYN flag to that port in this IP. Is this clear?
Yes.
So then this IP answered to you, answered to my Kali machine, to my source port from his 443 to my source port with a SYN-ACK.
Right.
And then I answer to that machine with an acknowledge. Three-way handshake. SYN,
Okay.
SYN-ACK, ACK. And as you can see, after that, look, they even say hi, client hello, and the session was established. And then, as you see, it's encrypted traffic, TLS, now. Now it's a different protocol, TLS, or different content inside the packet, TLS traffic. TLS, encrypted. You see? We can't understand what is going on because it's encrypted. If you want to take a look about what is going on inside, let's say this one, we are not going to understand nothing. Look, encrypted. It's encrypted. Let's take a look at UDP traffic. Let's say UDP dot port equal to 53. Look, this is UDP.
Okay.
As you see, no flags. UDP do not use flags. No. UDP just send and send and send and send traffic.
Right.
And
So now,
go ahead,
I'm
go
sorry.
ahead. Go ahead.
You were saying like if you wanted to abruptly finish, is this where you would use that?
No,
like when you're done?
No, if you have an abrupt finish, you are going to use a reset.
Okay.
Let me show you. Nice questions. We have time, so I can explain that part. In a moment, I'm going to explain you.
Okay.
Don't let me forget. So look, UDP, this traffic, well, DNS protocol is using UDP in the 53 port. So look, the first resolution was related to Mozilla, and then after Mozilla, you have other traffic, and in some moment, we are going to have the SecPro part. I can say, and DNS contains, let me see if I can use that filter, contains, no. I can look for SecPro. There is different ways to find it, but I'm going to show you that in a different session. But let me look for it. Say browsing, Firefox, DigiCert, blah, blah, blah. SecPro, look, SecPro.
Okay. So it's sending it to you because you made the request.
Exactly.
Okay.
I made the request to the DNS server, and the DNS server, look, the query, the first query was here. Standard query. A register. There are different registers in DNS. You need to understand the different registers, and each one of the protocols works in a different way. You can take a look about the DNS registers. That's so important. Very interesting thing. I can create a session with that. But well, SecPro, that's a query normally. And look, in that query, you can see inside the protocol. Let's see, in the internet protocol, we have the fragments, UDP. Look, user datagram protocol, UDP. And here inside the domain name system, we should have the query. Look,
Okay.
standard query, questions 1, and you can see the secpro.llc. You see the secpro here, you can see here. The query here, you have with query, secpro.llc, type A. Why type A? Because DNS have different registers, as I mentioned. You can take a look in Wikipedia. You can query a very nice thing. You can ask DNS records, and you have Wikipedia DNS records, list of DNS record types, and I'm going to copy this for you in the chat.
Thank you.
No problem at all. Well, so you give me a very nice question talking about the closed port, etc. So let me show you. I'm going to use a tool that was the last part of this session. For today's session, I want to talk about Nmap. Nmap is a tool that allows me to query different ports in different ways to know if the port is open in a specific machine. So let me show you. I can do this. I can start my Wireshark again. I close it. Yeah, I think I close it. Well, I can start sniffing. And let's execute a simple command. We're going to say nmap, like network mapper. And with nmap, you can query specific ports and specific protocols, and you can use specific flags. Let's try to detect an open port in a specific machine, like a website called scanme.org that we are allowed to scan because it's legal. Normally, it's not legal to scan ports if you are not authorized to. If you do a port scanning to a website and you don't have authorization, can be illegal. It depends about different parts, different states, different countries. But my recommendation for you is never scan ports in a website or in a server if you are not allowed to by the owner of the infrastructure.
Okay.
It can be illegal. So let's do this. nmap-st against scanme.org, and you are going to see. It says that scanme.org, that is a website. You can take a look. Let me stop the sniffer. So perfect. Let me show you that scanme.org it's a website. They create Nmap. Nmap is a beautiful tool, one of the most marvelous tools in the history in ethical hacking, pen testing, blue team, red team, etc. Because Nmap allows you to know the open ports in a server. It was created by Fyodor. It's a person that I admire, and well, he creates Nmap. It's an amazing tool. You are going to enjoy, love this tool. So look, Nmap says that in that server, you have the port 22 open, 80 port open, and these two ports open. You see? So let's see the behavior of an open port and let's compare with a closed port. So we can say TCP.port, an open port like 22, equal to 22. Look, what we sent was SYN, receive a SYNAC, and then an ACK. And then the Kali machine closed the connection. Why? Because Nmap already knows what we need. Nmap knows that this port is open and then say, okay, bye, see you, thank you. That's it, right? But let's see the behavior of a closed port, like 21, FTP. We send a SYN packet, but the port is closed. So the machine answered with a reset acknowledge.
Okay.
So port is closed, don't allow us to connect.
Right.
You see?
Makes
Perfect.
sense.
Is this clear for you?
Yeah, it makes a lot more sense now. It's very interesting.
It's amazing. It's beautiful. You know, knowledge is beautiful. And I love what I'm explaining. And you need to use this to be in a blue team, red team, etc. You need this information. You need this knowledge.
Understood.
We have more time. I'm going to share with you. We have 27 more minutes for questions. So you can ask me anything in a moment. I'm going to share with you another link. This link with Nmap. And the next session is going to be related with port scanning, specific port scanning. Okay. So I'm going to share this link with you. Perfect. That's it.
Thank you.
So do you have any question about the concepts I explained today?
About the concepts, no, you answered my question with that last example that you did. I guess my main question would be, like I have no exposure to cybersecurity, so this would be like my first dipping my toe in. Where could I get like the fundamentals of this?
Okay, of cybersecurity, you mean, or
yeah, or of this concept?
I published some links in my Twitter. Did you take a look of them?
I did not get to look at them, but I did see that you posted something
in my Twitter. I published. Let me show you. For this session, for this mentoring session, we are now in the mentoring part. So in this session, for this session, I publish a message saying, hey guys, girls, if previously to the session, I recommend you, if you can read these materials, can be good. So look, did you take a look at my YouTube channel and I say how to start in cybersecurity?
I just saw that this morning before I logged in, so I'm going to go watch that.
Okay, perfect. I'm going to explain a lot in that video, and I'm going to create the second part of that video with more more in-depth information. But look, for the training here, recommended materials to read or view before our session.
Okay.
So you have here the OSI model, another explanation about OSI model, and this one was related with networks, I think. Yeah, TCP-IP model. And here you have a video in my YouTube channel, the Spanish video. I have two YouTube channels, one in Spanish, one in English.
Okay.
This, I hope, it will be very nice if you speak Spanish, because you are going to enjoy these videos. But right now, my team is working in the translation of these videos.
Okay.
But you can take a look about them. It's traffic analysis, and you can mute me if you want. You just can mute me if you don't want to hear the Spanish, and you can use subtitles in English.
Okay, that will work.
Yeah, and it's great. To be honest, look, you can configure the subtitles in English. Give me a second. You have English subtitles and what is English? Oh, it's weird that I can't see English. Oh, it doesn't have the English subtitles. It's weird.
Where are you located, Mr. Pereira?
In Washington.
Oh, okay.
But it's so weird. Well, I hope you can see it. But, well, here I explained the wireshark, a little bit about the concepts I explained today. You're going to see them here. You're going to see the commands. And I'm going to translate this video. It's very interesting, very, very useful, because I go deeply in the flags, etc., etc. And those are a group of videos talking about traffic analysis and then threat hunting.
Okay.
But, well, and the English channel is secpro.llc. You just need to look for secpro.llc. And that's my English channel. Just starting. And I have where to start in cybersecurity video. So I explain how to start, right? So you can see, okay, you need some specific concepts like networking concepts. So I explain each part of each part in detail. So you start. This is in English, so it's okay for you.
Yeah.
I love it. Yes, I'm going to be your trying to access your net. So basic knowledge, operating system, tools, and scripting. So I explain in each one of the cases where or what kind of concepts you need. Then I'm going to create a video for each one of them. So I'm going to show you sources of information that you can use.
Perfect. That sounds amazing.
Perfect.
I'll definitely be staying tuned. And I'm going to follow you on Twitter so that I know when your next session is, because I definitely want to continue to learn more about this.
Perfect. Perfect. I think the next one is going to be in Twitch. I think. Okay. It's going to be in Twitch. What else do you want to know? We have time. I am going to spend the time with you.
Well, what do you do?
Well, I am the CEO of SecPro, SecPro LLC. I have more or less 25 years experience in this field. I do pen testing, ethical hacking, forensics, malware analysis, and I train people, and I do consulting. We provide consulting for many companies in the world, and we are starting in the United States. I'm looking for people right now. We have one pen tester, one sales girl, but I need to fill another sales associate position. And we are starting in the United States. We are in other countries. We are in 9 countries right now, but I'm looking to hire people in the United States.
Okay, awesome. Because I really just stumbled upon cybersecurity, and I was doing a little bit of research, and I did find ethical hacking and like pen testing to be my interest. So I was actually looking to learn more about that. And I came across a video that said that we should start with the CompTIA certification. Would you suggest that?
It's a very interesting question, to be honest. There are different certification companies that can help you to start in your career. And sometimes there are tuition free, or sometimes they provide free certifications. CompTIA is a good one. You can look for. You can start with Network Plus. Network Plus can be interesting because some people say, you need to start doing baby steps before to run. So you can start with that one. It's a good one. It's a good certification. After that, you have Security Plus, if you are talking about CompTIA. But there are other entities like Easy Council. If you want to go in ethical hacking, penetration testing, etc., well, we have Easy Council. I am instructor of Easy Council.
Oh, okay.
Yeah, you can look for me in internet and you are going to see. So awesome. Easy Council gives you certifications like CEH, Certified Ethical Hacker, LPT, the Sensor Penetration Tester, etc. That's Easy Council. So you can take a look about Easy Council.
Okay.
You have SANS if you have enough money, but normally SANS can give you a free training if you accomplish some specific parts. I think SANS it's encouraging women to start in cybersecurity. One of my pen testers have 3 SANS certifications.
Okay.
And it's amazing and was free training.
Nice.
Yeah. You need to reach them. I'm going to copy these links for you in the chat. So Easy Council, SANS is, all of them are great. Some of them, problem for some of them is price. Some of them are more expensive than others.
Yeah.
You can take a look to SANS. There are ISC Square. But to be honest, if you don't have right now the budget, in YouTube, you are going to find a lot of knowledge. And sometimes people like me, there is a lot of, we have trainings in English that you can take a look in our website if you want.
Okay.
And in some moment, we are going to have international certifications. Nice. Yeah. You have another entity like it's called ISC Square. They have cybersecurity certifications as well. Look, 20% discount.
I did start this one.
Okay, perfect. And you have another one. There is a lot. There is a nice. I already published that a lot of time ago in my Twitter. Different entity certifications that you can follow depending what you want. But you need to, my recommendation for you is to start with the knowledge and then go to the certification. Because sometimes you just have some specific time to present the test. So if you are not ready, maybe you need to pay for more time or for extension. So it's better if you are prepared and then you take the certification. And in YouTube, you are going to find a lot of guides for different certifications. In one moment, my recommendation for you is go for the OSCP. It's one of the best because it's practical and it's very, very well known in the field.
Okay.
OSCP. I'm going to start publishing more content. Well, in my YouTube channel, you have everything about hacking, but in Spanish. That's why we are right now changing or translating. Let me show you, David to English. Sorry. So this one, cybersecurity for everyone. So in my channel, you have everything about hacking. Look, I have an entire training in hacking. Yeah, but the problem is in Spanish.
I wish I spoke Spanish.
Yeah, look, ethical hacking to web applications. But again, you can mute me and you can put
The caption.
the subtitles.
Okay, that will definitely work. So when you're looking to hire pen testers, what do you want them to have?
Well, it depends about the position. If I want a senior pen tester, normally I expect that this person comes with some certifications like the CEH, OSCP, that kind of EWPT. I forgot to mention EWPT certification. I expect that. If I'm hiring a junior penetration tester, normally what we do, it's an internship
Right.
for this person.
Okay.
So but it's not a paid internship. The internship can be what with the low approves, I think it's 3-4 months of internship. And if this person have it's a good quality and have the potential, normally we hire this person.
Okay.
So if you want an internship with us, send me your resume.
Okay, I'll definitely do that. The boot camp that I'm enrolled in right now, it just started in September. It's due to wrap up in about February or March.
That's right.
But I definitely am very interested in cybersecurity, and I believe this is a sector that I'd like to go in. Right now, I'm working on data analytics, so I'm learning SQL and Excel. But
that kind of knowledge is going to be useful for you. Don't worry about it. You know, in ethical hacking, penetration testing, everything you know can be useful.
Perfect.
Awesome.
So what type of companies does your business cater to as far as providing security?
Any type of companies, because everybody needs cybersecurity. If you have a website, even if you are a very small company, even if you are a person that creates, I don't know, some kind of ornaments or so, and you use your social networks to sell it, you use a website to sell it, you need cybersecurity, because malicious actors and nefarious actors can send you a malware and infect your computer and take control of your social networks. So your business is going to be ruined because you need to start again creating your entire network. How much time you need to create I don't know, 1,000 followers, 2,000, 3,000, etc. So everybody needs cybersecurity. One of the things we want is to break this conception or misconception that people sometimes think that only the big companies or medium to big companies can have cybersecurity. No, everybody have the need of cybersecurity. That's why our initiative, you know, it's called Cybersecurity for Everyone, because everyone needs cybersecurity. Normally, we work with small companies, medium and big companies, companies of the size of Coca-Cola, or companies. One of our small clients, it's a school with I don't know, 5, 6 teachers. That's it.
Okay.
So we can work with any size of company. We love the small companies because we love when they realize that that cybersecurity is important and they need to worry about it.
Right.
Yeah.
Wow. So I learned a lot today. Thank you so much for coming.
My pleasure. My pleasure.
I took some notes here. I have a new folder with all the links that you gave me. So I'm going to be visiting your YouTube and just going over these again.
That's great. That's great. So please, if you want, take a look of to our website. And in the website, I'm going to publish a community page. I'm going to publish resources there. My GitHub is there. I have a Python training. I'm going to put information there. And well, I'm trying to be very active in social networks, sharing knowledge and doing sessions. The next one is going to be in Twitch, maybe in 2 weeks or so. And we're going to talk about maybe the basics of the ethical hacking or something like that. So I hope it's going to be interesting.
Sounds good. I will definitely be there. And I'll certainly keep in touch with you because I definitely want to pursue this some more once this boot camp
That's perfect. You are more than welcome to the internship to our company if you want.
Awesome.
And well, that's perfect.
Thank you so much, Mr. Pereira. I really appreciate your time.
My pleasure. Thank you so much for being here.
Thank you. You have a great day.
You too. See you.
Thanks. Bye-bye.
Bye.